Lesson 7. Types of Static Stability Diagram, SSD. In the previous lesson, I loaded the ship's tween decks fully, which somewhat reduced its stability reserve. The area under the SSD curve to the x-axis. However, even after reloading the vessel, met the 4 considered stability criteria, and this is normal if the ship is loaded correctly. Because I have always followed the golden rule of loading, heavy cargo, down, in the holds, light cargo, on top, in tween decks. But what happens if the cargo mate is careless and disregards this rule? Now in the animation I will show what happens to the SSD curve if the rule is neglected. We are seeing a decrease in all stability criteria. 1. On the screen is a ship with poor stability. All stability criteria known to us are at or below the limit, and the area under the diagram is frighteningly small. Let me remind you again, the area under the static stability diagram is a reserve of stability. Without any calculations, looking at this diagram, I can say that this ship is not very stable and she is not far from trouble. It is necessary to take measures, to redistribute the load, to take bottom ballast, etc., in general to increase stability. 2. I return to the initial loading and increase the curvature of the initial section of the diagram. On the screen is a typical SSD of high-sided vessels, looks like a passenger ship, where good stability is achieved by the height of the side, with a relatively low metacentric height. The vessel has a good reserve and stability, look at the area under the curve, and buoyancy with soft rolling. 3. I straighten out the curve of the diagram. We get a diagram of static stability typical for a cargo ship. It is usually a wide and low draft vessel with a high metacentric height. Sharp and fast pitching is not critical here, the main thing is to take more cargo and transport it away and do it safely. 4. I'm dropping the beginning of the curve below the x-axis. We get either an incorrectly loaded vessel, or a vessel that, for some emergency reasons, received a negative initial metacentric height. Here the ship's center of gravity is located above the metacenter, thus, the ship is in a position of unstable equilibrium. Any heeling moment, gust of wind, wave, tug, from any side will force the weight displacement D to work on the heeling moment, until the ship acquires a stable balance with a list at point θ1. Such a diagram can be seen with timber carriers going into overload, or tankers with large free surfaces in cargo tanks. The rules of all major classification societies, for example, Lloyd's Register, Bureau Veritas, as well as our Maritime Register, prohibit the operation of ships with negative initial stability. It is impossible to straighten such a vessel by transverse movement of cargo. This can lead to even worse consequences. The ship may roll onto the right side with even more heel if it does not capsize. You should restore the initial stability by lowering the center of gravity G. If you are at the pier, move the heavy load down, the light one up into the tween decks. If this happened at sea, throw deck cargo overboard, life is more expensive. If the freeboard allows, take the ballast into the bottom tanks. It is possible and necessary to fight for the ship. The large positive segment of the SSD above the x-axis suggests that all is not lost. 5. I omit the starting point of the graph. We get a diagram of a vessel loaded incorrectly, or a cargo shift has occurred. Here, the vessel's center of gravity is outside the centraline and the vessel is heeled in the direction of this offset. It's not pleasant, but not fatal. The ship has lost some of its stability. Reduced minimum overturning moment. This is where the transverse movement of the load makes sense. If this happened at sea and there is no way to move the shifted cargo, level off with the side ballast tank of the opposite side. The main thing is that the loosened load does not shift in the opposite direction, otherwise the situation will only worsen. Do not rush, and first of all, you need to find out the cause of the roll, then calculate the situation on the computer, and only then make a decision. The most basic types of static stability diagrams are considered and analyzed. Of course they are not exhausted. Each situation is unique, as is the corresponding SSD. Resume. 1. With any deterioration in stability, such as the appearance of an unjustified list, an increase in the rolling period and freezing on the reverse movement, it is necessary to clearly determine this effect. Determine measures to eliminate it. Calculate these measures on the load computer and only then act. Haste is prohibited. 2. The rules of any classification society prohibit the operation of a vessel with negative initial stability, negative metacentric height, GM. In this situation, it is necessary to correct the initial stability by lowering the ship's center of gravity. In no case should the vessel be straightened by the transverse movement of the cargo, which may lead to a worsening of the situation. 3. With a transverse displacement of the center of gravity G and obtaining a constant roll, the transverse movement of the load is justified. Ideally, return the load to its place and fasten it, but this is often not realistic. It is necessary to fix the cargo in this position, eliminating its movement and take the straightening ballast into the side tank, preferably the bottom one. Good luck, and all the best.